Now we have Norton's equivalent circuit, and in this circuit the resistance Rn and the load resistance RL are parallel to each other. They are parallel. Therefore the voltage across AB, that is the voltage across RL, can be calculated as, therefore in Norton's equivalent circuit, VAB equal to, that is the voltage across RL, that is the voltage across RL, that is VAB, can be expressed as voltage equal to current into resistance. That is, what is the current here? The current is IN is flowing, and what is the resistance? They are parallel to each other. It means that current, that is IN, into resistance, that is RN RL upon RN plus RL. Now this is the voltage across A and B in the Norton's equivalent circuit. Now put the values of IN. Now we have the value of IN here, that is E upon R1, and we also have the value of Rn here, R1 R2 upon R1 plus R2. Put these two values in this equation. Therefore what we get? Therefore IN equal to, that is E upon R1 into Rn, that is Rn equal to R1 R2 upon R1 plus R2 into, that is RL, upon Rn again R1 R2 upon R1 plus R2 plus RL. Now if we simplify this, जर आपण याला सिम्प्लिफाय केलं तर आपल्याला कसे मिळेल? या ठिकाणी हा जो E आहे हा इकडे येऊन घेतला, R इकडे घेतला तर R1 कॅन्सल होऊन जाणार, म्हणजे या ठिकाणी काय मिळणार? E R2 upon R1 plus R2, that is E R2 upon R1 plus R2 आणि RL तसाच राहणार, आणि upon RL plus, that is R1 R2 upon R1 plus R2 into plus RL. This is VAB. This is equation number 5. Now if we compare equation number 2 and equation number 5, that is we have this equation number 2, E R2 upon R1 plus R2 into RL upon RL plus R1 R2 upon R plus R2. That is, we have the same equation. Therefore from equation, these two equations, voltage across A and B in both the circuits, voltage across AB, that is voltage across RL, in both the equations, in both the circuits are same. This is the proof of Norton's theorem. Hence Norton's theorem is proved. That is from equation number 2 and equation number 3, equation number 2 and equation number 5. The voltage across RL in both the circuits, that is in the given circuit and in the Norton's equivalent circuit, are same. Hence the proof of Norton's equivalent circuit. Now if you are given any circuit, any two terminal linear circuit, you have to Nortonize that circuit. Then how to Nortonize a given circuit? There are some steps, as we have seen in case of Thevenin's theorem. Here also there are some steps. Now step 1 is disconnect the load resistance. Disconnect the load resistance RL. Load resistance RL. Second step, from terminals A and B. A and B terminals मधला लोड रेजिस्टन्स काढून टाकायचा आहे. स्टेप 2 is put a short across the terminals A and B. जो A and B मधला लोड रेजिस्टन्स काढला त्या लोड रेजिस्टन्सच्या ठिकाणी आपल्याला एक शॉर्ट पुट करायचं, म्हणजे एक वायर टाकून द्यायची. स्टेप 3 is remove the short. Step 2 is put a short across the terminal A and B and calculate IN, that is calculate IN. Now step 3 is remove the short from terminals A and B and calculate R equivalent, that is equal to RN. Here the IN, that is the put the short across the terminal A and B and calculate IN, that is the शॉर्ट केल्यामुळे त्या करंटला आपण म्हणू शकतो शॉर्ट सर्किट करंट ISC, that is equal to IN. And here remove the short from the terminals A and B and calculate the R equivalent, the equivalent resistance of that circuit, that will be the RN. Now step 4 is calculate IL here by putting or आपण याला म्हणू शकतो या स्टेपला आपल्या हिशोबाने लिहू आपण प्लेस or connect the IN and RL in parallel and also connect RL at terminals A and B. These are the 4 steps to Nortonize any given circuit. For this, now consider any circuit. How to Nortonize this? How to Nortonize the circuit? For this, let's consider we have a circuit like this. We have a given circuit. This is the given circuit. Suppose we have a voltage source here, we have a resistance here, we have another resistance here, and we have here the load resistance RL. That is, suppose the load resistance RL is of 5 ohm, R2, this is R2 which is of 6 ohm, and this is R1 which is of 4 ohm, and this is E which is of suppose 10 volt. Now suppose we have this is the given circuit. Now apply or use all these 4 steps and Nortonize this circuit. In the first step we have disconnect the load resistance RL from the terminal A. That is, this is the terminal A, this is the terminal B, this is terminal C, this is point D. Okay. Now disconnect the load resistance RL from this terminal. Now step first, disconnect the terminal. Now and second step is put a short across the terminal A and B and calculate I. Now first we will disconnect this is R2 6 ohm, this is R1 4 ohm, this is plus minus E equal to 10 volt. Now we have disconnected RL and put a short across terminals A and B. Now we have to find out the current. Now in this case, if we place the short, all the current will flow through this circuit, and this current will call the short circuit current, which is nothing but the IN. Now we have to find out the IN. Now for this, what is the IN? That is ISC here. Short circuit current will be equal to voltage, voltage upon resistance. What is the voltage? Here 10 volt upon what is the resistance? Now the resistance of this circuit will be, the current will flow through this short but not will flow through the R2. It means that the resistance of this circuit will be only R1, that is equal to 4 ohm, that is equal to 2.5 ampere. That is IN, that is IN equal to 2.5 ampere. Now we have this value of IN here. Now you have to find out RN, and for this we know that to find out RN, what is the third step? Remove the short from terminals A and B and calculate R equivalent. Now from this figure, from this circuit, we will remove the short Now we have removed the short. This is R1, this is R2, this is 4 ohm, this is 6 ohm, and this is plus minus E equal to 10 volt. Now we have, and also remove the short from terminals A and B and calculate R equivalent. Also in step 2, in step 3, we have forget to mention one thing. Remove the short from the terminals, also terminals A and B, and remove the battery and replaced it by its internal resistance, and then calculate R equivalent. What is the remove the short from terminals A and B and remove the battery and replace it by its internal resistance and calculate R equivalent. This is the step 3. Now in this case we will remove this battery and we will connect, and we will replace it by its internal resistance. And in this case we have not given any internal resistance here. It means that the internal resistance is 0. Therefore internal resistance is here 0. Therefore now these two resistors are parallel to each other. Therefore the R equivalent resistance, which is equal to Rn, here we can be calculated as R1 R2 upon R1 plus R2. That is equal to R1 is here 4 into 6 upon 4 plus 6, that is equal to 24 upon 10, that is equal to 2.4 ohm. This is Rn. Now our step 5. Connect IN and RL in parallel and also connect RL at terminals A and B and calculate. Now therefore step 4 is connect IN and RN and also RL at terminals A and B. This is RN, this is IN, and this is RL, which is equal to 5 ohm, which we have given here 5 ohm. Okay, 5 ohm. Now here RN is here 2.4 ohm and IN is here, IN upon काटलेला 2.5 ampere, that is 2.5 ampere. Okay, now we have to find out the current flowing through this RL, that is equal to IL, that is the load current IL. Now for this, how to calculate the load current? Now in this circuit, IN and RN are parallel, that is, this is the Norton's equivalent circuit. Now here the current passing through IL can be calculated as IL will be equal to IN into RN upon RN upon RL, RN plus RL.